Okay, now we had a little trouble answering why this thing has to have 3 rows or 3 columns or whatever. It does, okay? We know it does, but we don't necessarily know why, okay? And you said because this thing has to have 3 columns because this has 3 columns. That's not right, okay? The fact that you got, this one has to have 3 rows because this one has 3 rows. It doesn't. You can multiply 1 row by this column, okay? This tells you that the rows have to have 3 numbers in them because the rows have to have equal number with the columns, which nobody wanted to tell me. Meaning that you don't totally understand all the connections. And that's the simplest one, first thing we learned, right? It's so obvious that you didn't think to say it. You know it. If I give you a row that doesn't match the column, you say those aren't compatible. So you know it perfectly well, but you got to retrieve it in the order that allows you to prove the result. And the reason this is so important is it has to do with the dimension of this space and the dimension of this space. Okay? It has to do with rank and nullity of the matrix and its inverse and all kinds of things. Okay? And these are really big things right now. So we want to establish everything from the most obvious basic definition of what it means to multiply matrices. You start by multiplying rows by columns, okay? So each row has to have 3 numbers to match up with the column. Well, that doesn't tell you that this matrix has 3 rows. It tells you it has 3 columns because every row has 3 numbers in it. That will give you a matrix with 3 columns, right? Now, nobody's yet told me why it has to have 3 rows. Want to take another stab at it before I let the cat out of the bag? Well, if you multiply the first row by the first column, where does the result go? I think you just looked at it and nodded.
Yeah, that it would go where x1 is.
Like, you're going to go in the first row, first column over here, right?
Yeah.
Okay. Now, if you happen to have a second row, where does that go? You multiply the second row by your column over here. It's going to go here, right? So can you conclude how many rows you're going to need to get this? Yeah, you're going to need a row for every one of these numbers. Okay? That's except to understand transformations in the dimension of the space that you get. Okay? The dimension of your range space. And of course there's rank and nullity involved in that too. But y'all know that stuff. You can get the rank and nullity of a matrix. You got to put it together into a picture of a transformation. So there's a little hang up there, so kind of take a note of that, right? Make sure you understand that the reason there are 3 rows is because there are 3 numbers in the column. And the reason there are 3 columns is you need 3 numbers in each row to multiply this. And if it was 4 here and 2 here, your answers would be different. Well, in this context, you're not going to have that because you have a basis consisting of eigenvectors, okay? So what we're really trying to do, let's come back to the original problem. We want this matrix to represent the transformation that does this. Well, that does this, in other words, okay? So what numbers have to go in the first row?
1/2, 0, 0.
Yeah, and you've told me that a long time ago. You saw it. But when you're unable to answer the original question, I thought we had to digress, okay? So you're way ahead of me in this. But make sure you understand that. Okay? And the second row is?
0, 2, 0.
Yeah, 0, 2, 0. 0, 0, -1. Okay? So A is the matrix with respect to the basis B. Okay? What would the matrix be with respect to the standard basis? You did it in your homework. But we're in a context here, okay? So we got to adapt to the context.